Hello.
Okay, I'm Khyati. I work at Morningstar, downtown Chicago, and we work on retirement products, helping people manage their retirement 401ks. And one of my projects recently, we've used React with TypeScript, Node with TypeScript, and those Node powers the lambdas behind it. It's been about a year, and so far we've been very happy with using the TypeScript. So I'm here to spread the good word of TypeScript. What is it? It's a typed superset of JavaScript. And when you say typed, it means it provides static typing that we already know. It's TypeScript. But by superset, every valid JavaScript is valid TypeScript, which means you don't have to be worrying about extra dependency when you start using TypeScript. If something is not supported, you can always type out your plain JavaScript and it will compile correctly. And this philosophy of TypeScript has helped pick its popularity. There were other options available in the past, Flow, and I think Clojure.js, I do not know much about it, but they had a different philosophy, and TypeScript said, okay, we'll provide static typing, different language, but at the same time, if something is not as per our standards, we won't be rigid. We'll have type safety as a slider. You can tune it to how much strict you want to be. And traditionally, advanced features of ES6 which are under consideration, ECMAScript features which are under consideration, they're already available in TypeScript, which makes it makes your code future ready in a way. Again, like I said, type system is optional. It's like a slider as to how much you want your type safety to be. Also, TypeScript will not increase your package size because it is a development time dependency. Whatever is, once you compile it, it is pure JavaScript, and that's what you need in your final package. So if people argue, the people who are little concerned about having TypeScript, it's not going to increase your package size at all. This project started in 2012 at Microsoft, and it's currently open source, but it's powered by Microsoft. In fact, the lead architect of C# is the one who's driving this project, which is why you see a lot of makings of C# in the syntax of this project.
Sorry.
So when should you use TypeScript? I mean, every choice you make has pros and cons. Typically, I would say you need TypeScript for large-scale JavaScript projects, which is why it emerged in the first place at Microsoft. You need, in a large-scale project, you need to be able to reason about the domain. And for reasoning, you need to have a class structure. A good class design usually helps with limiting the translation required from code to the real world. And that is where you get speed, and that is where you write readable and maintainable code. This is something I've seen. A poor class design can lead to project failures, and one of the companies I was working for in the past, they were so bad in class design that company filed for bankruptcy. It's in Kansas, you can look it up. So that's the very high software cost. Also, your language influences your thought process. For example, if you're writing in Haskell, you will not think of designing a class. Your first idea will be to think functionally. Similarly, if you're writing in JavaScript, you will think a certain way. With TypeScript, you will think in an object-oriented way, and because you want to model the domain, it's best to use something which enables you to think in that way. So your solid principles, which power your object-oriented design, they become easy to write in TypeScript. Again, code sharing, you want type safety, because as a class designer, you want to limit how a client uses your class. And when you limit that, you will kind of control the misuse of your class. So for that, code sharing and static typing, you need TypeScript. And the fourth point here is something relevant to me, because I'm a C# developer. My team had C# Java developers, only one developer who knew front-end development, and she was 1 year into her career. So we had to have a middle ground wherein you can think in terms of the traditional patterns, but you can eventually end up writing front-end and Node.js code. Also, if you see, these languages, Java and C#, they're very mature in terms of their patterns. And all these gang of 4 patterns, everything, none of those emerged in the JavaScript world. So if you want to reason about them and express yourself in your thoughts in these patterns, you're better off using something which supports it. And if you know how V8 engine works, V8 looks for pattern optimization, which means if you have an array of homogeneous objects, all of which have the same keys, which are your properties, V8 will initialize those keys only once, and it will set just the properties for different elements of the array. So you reduce the duplication of the keys when you instantiate, and that improves performance. And because you have static type checking, your resultant code has a very high amount of patterns, and these kind of patterns, when your engines detect, they improve your performance at runtime also. There are downsides of using TypeScript. I mean, one of that boils down to static versus dynamic typing. Whoever thinks real developers don't need autocomplete is wrong in my opinion. You are better off using the limited cognitive power you have in reasoning about every in reasoning about your domain rather and thinking of high-level pictures rather than trying to fix typographical errors. Early feedback is critical. In the absence of type checking, you would write a unit test, but with unit test, your feedback comes when the CI pipeline runs. It comes when you run the unit test, not when you're typing it out, and that is at least 10 minutes gone per case. So early feedback is what static typing provides. You can prevent common typos like this. A typo like misspelling length is not even worth 5 minutes. Many a times we call function, we forget the parenthesis. That's also very common. And like you don't have all parts in an if-else returning from a function. You don't want to test everything in and have 100% coverage for such use cases. So in these early feedback cases, you immediately get help with static typing. That said, dynamic typing is also good if you want to build a fast, small application. Static typing is an overhead in some ways. So depending on your use case, you could use or not use static typing, but again, it's a slider with TypeScript. This is the type system which is available to us. In JavaScript, you have, I think, 6 primitive types, and everything other than that is an object. With TypeScript, you have a much larger variety. Specifically, if you see enum, that is not available easily in JavaScript. And the any type, that's also significant. With any type, you in a way switch off the type checking of TypeScript entirely. Any means you can go freestyle, and it is dynamic type. There is no compile time safety provided for something which is defined as any.
Oh yeah, we have that in JavaScript.
That's the built-in.
It's a type.
So you might as well not use TypeScript that way, but it has its own advantages. For example, when you're migrating a large-scale JavaScript project to TypeScript, there's no way you can take the entire Herculean task on day one. You're better off migrating piecemeal, module by module, and that's when you would first be having your any type, and then gradually introducing types into your modules. So that has its purpose, but if your code is littered with any types, you might as well just switch to the traditional options available to you. So now coming to the topic of this presentation, designing object-oriented programs with TypeScript. Before that, how does inheritance work in JavaScript? Inheritance is the basic mechanism of code reuse. There are others, but inheritance is the primary one of them. In JavaScript, there is no notion of classes. What we have in ES6 is syntactic sugar. Traditionally, there is no concept of classes in JavaScript. Every object is a collection of key value pairs, which means your properties, they are your keys, and the values they assign are the values, basically values of the property. And everything that is not primitive, which is your string, your number, I think null undefined boolean, that is an object. Even functions are objects. And this is something people like me from traditional backgrounds never ever understood. So I've just written down, and I do not know what this means, but I don't know how functions can be objects, but they are. And in fact, a class definition, if you want to have something like a class in JavaScript, it will be kind of a function with its own closure and its own variables. But the concept of method, which is a function of an object that is as an instance variable of an object, or this I'll just read out. When uses objects with new keyword, instance object returned with properties set from this keyword within the function. So this I do not understand. I have no idea. I mean, these are the reasons why I use system TypeScript. And there is something called prototypical inheritance, where there's this prototype chain. You have a function which has its prototype, which goes to a parent prototype, and that's how the inheritance works. So that the last point summarizes what I understood, that JavaScript inheritance is way too convoluted. Solution: TypeScript. What is an object versus a class? And a class is kind of a blueprint of an object. For example, chair is a notion, that is a class. Each of these chairs in this room is an instance of the notion, and that is an object. With TypeScript, you first define your type, which is a class, and you instantiate it with objects. So, coming to our TypeScript project, the first thing we would need is tsconfig.json.
Much better.
Okay. This tsconfig is the global tweaking of TypeScript, and it provides many options. That's the list of options you have, and sub options also. We've used just two for now. First is the target which you want. You do not need any other transpiler if you're using TypeScript. It has its own, and I am targeting ES5 as the final JavaScript. I have source map, which is for debugging purposes, and those two are some things which I need for now. The first problem I'm trying to solve is something of a factory pattern. Factory pattern is something you use when you want to decouple the construction and outsource the construction of an object. And some use cases where you might use it is the object construction is very complicated, or you want to maintain a pool. For example, you have a database connection, and you want to control only 5 instances to the database connection. You don't want too many connections happening to the database and swarm it. When you want to control this kind of instantiation, that's when you use a factory pattern. And a typical signature of a factory pattern is something like this. You have something called create instance, and that returns you the instance. In our case, we want to create a validation factory wherein you give your use case, and it could send you validation object in return, which is you validate a string, email address, phone number, name of city, etc. The first step of this is to create a base class, because your class would require a return type. So I create a base class, which is my iValidator. Few keywords here: interface and the name of the class. You always name a class with a common noun. That is the way you design classes. And an interface is a class which only has methods. Interface is only behavior inheritance, not state inheritance. And here you only have a method which is validate, which is of type string, returns a boolean. Anything which inherits this interface would have to adhere to the signature. I have a couple of instances of this interface inheritance. One is phone number validation, which is implementing the interface and returning something on the basis of it. I have email address validation, and we'll go for something called city name, where only some cities are valid. So Also note the problems tab as to how quickly you can find feedback in TypeScript. Last, one more thing, in any project of TypeScript or any C# Java in general, your class should be in a single file, and your file name should match the class name. And each of these files is a module in itself. So export class, because the file name is city name validator, I'll go for that. And it implements the interface iValidator. It imported and it's saying something is wrong with it. I will say fine, fix it for me. Oh, it's saying no quick fix is available, so I'll.
No quick fix.
This is fun.
Visual Studio Code falling over.
And it says, okay, this class is of type iValidator, so it has to have certain behavior which is of validation. I'll say fine, quick fix. Implement the interface, and it implemented the interface for me. Right now it's method not implemented. I'll implement it. String, okay. Okay, this should be fine. No, it's not. It should actually be wrong. Else return false. So this is the implementation of the interface. Let's try.
So do you mean to say from import from the file name or something? So if the files live in the same directory, you still have to kind of exclusively specify the file?
Yeah, you're importing the type also over here.
Yeah, but I mean, it's like in the same directory, the iValidator thing. So you still have to specify the file?
Yeah, I think so, yeah.
Yeah, that's just JavaScript.
The not cool part is all JavaScript.
Sort of double equals, but I haven't seen one in a long time.
Sorry?
I'm just teasing about double equals.
He wants a triple equals.
Oh, yes. I should have remembered that. Okay. Any instance of this city name validator would
But it's type
give me
type strings.
would give me a true valid city if it's Chicago, else it will give me false. If I try to use it in the client, factory client, let me try. Not create. This is again, anytime you have a factory class, your signature should include this and nothing else usually, so that you prevent objects from being created in other ways. Types dot, you only have two types over here. So let's go to types and see what it is. This is something called enumeration. Anybody who's used C# Java would know about this, but you basically have when you have a list of constraint types, you're better off using enumerations instead of numbers for type safety. In this case, this means the first one is a 0, this is a 1, and I could have used 0 and 1 and my code would have run fine, but your value is in having readable code, in connecting to the developer 5 years on the line and having that developer understand why you wrote this. That's why you use enums, and if I saw the translation of this enum in JavaScript, you will see how complicated it gets. But I'll have one more over here, which is okay. So now I should be able to have the intelligence over here. Yep, I have it. And let me try to okay, have something else. And expect this to return false. Also, just see the type of this. This is called type inference. This is of type iValidator, which is the base class of this interface. While I'm at it, I'll just show you how debugging works in TypeScript. Let me just regular standard F10 to step in, F11 to step in. I did not know this. Okay, this is the factory. The case we have provided is city name validator, which is of type 2. So this is where I mentioned enums. Behind the scene enums are just numbers. You have 2, which is the third enum we added starting from 0. But when you read, you do not want to try to understand what 2 means and what 1 means. So that's you're better off using this. It came out directly because there's a mistake over here in my code. It should throw not implemented exception over here as the default case, and that's okay. Let's try it. Let's run it this time. Go to the case and you should get an exception, which I'm not catching over here. That's why there's nothing seen over here. But basically we're missing a case, so we'll have and here we create the instance of city validator. So all the instance creation is within your factory object. Coming back to the client, we want to assign this to a variable, and any variable you name with and is usually Boolean variable. This is of type Boolean. Yes, that's your Boolean, and you will log it over here. It should keep returning a false basically. Yeah, this is where it's giving you the output. So that's the factory pattern. But one interesting thing over here is to see the translation of what we just wrote in the actual ES5 terms. We'll start with the enumerator. This is TypeScript. This is your JavaScript. Having the equivalent functionality would be this. Your 0, 1, 2, 3 are over here.
Well, you would never write that.
Yeah. That's why you
not
don't
my
see terms in
equivalent.
JavaScript. Interface has no footprint on TypeScript. It's only for static time checking. It has no ramifications at the JavaScript level. So this is your JavaScript. Nothing over here for the interface, which is this. You don't even have the method validate in your interface because it's strictly for the TypeScript compiler to check it. But that's not the case for classes. You see, this is a class. It has the implementation of this method and the JavaScript of it. This is what I meant by function, whatever. This is how classes are in JavaScript. You have the function, you have the prototype of it, which has the method validate, and all of this. So like, I think you guys can make a decision of what is more expressive for you, this or this. So.
Well, if we interject, I actually do like TypeScript, but at the same time, you've got to realize, I think, and I'm kind of doing this off the cuff,
that this is the actual expression of the TypeScript rules more so than your intent of the code that you wrote.
Yes.
So this is going to be a little more complex than somebody would basically, write by hand. Having said that, yeah, there is lots of help in TypeScript that Java does not afford you.
Yes, and again, this again boils to the point of diverse skill sets teams. I mean, anybody who's into hiring would know it's difficult to find front-end engineers and people who are experts at JavaScript. You might as well just leverage your experienced C# and Java developers and use TypeScript to design your model to classes faster. So again, it's multiple reasons. It might not be useful in some cases. It might be useful in some cases. One more thing I missed was the factory class. Yes. We have encapsulation in programming, and that refers to how you want your classes to be visible externally. For that, we have three options in languages: private, public, and protected. In this case, we have a public method, which is why it's available outside in the client class, which we use, create instance. Static. This is a static method is something which is available at the class level and not the object level. When you create an instance of an object, everything of the class is copied, that is the object's state. But if you have static, it is only once at the signature of the class and not at every instance of the class. So something like factory pattern would typically use a static method and not a method of this kind. The moment I use this, it becomes a class object method, which is instance method, and you have a problem over here. Which means you can't use it this way. You have to use it after an instance, and you create an instance like this, new. Now it's fine. But this you created an object instance which you did not have to create for the strict factory pattern principles. So I'll revert this over here. Okay. The second thing which is very powerful of TypeScript is the feature of generics. What I show you is a very, very simple example of it, but it's a very, very powerful pattern. Now assume you have an array this kind of an array is valid in JavaScript. But if you want to make sure that at compile time itself, you get to know that these are only you want these to be only numbers. How do you go about it? You have something called generics to your rescue, wherein you specify the type as a parameter while instantiating. So this will immediately give you an error. Something is wrong in this array, and this is compile time feedback. This is fine. And with the previous approach, you could even add any kind of object over here. This is going to disallow you from adding, for example, if you have a function like this. Actually, if you think this is an override, you don't have to specify it every time. The function will, TypeScript will infer it. So basically, hover over it, it will infer that it is a string. So specifying return value is actually optional in most cases.
But it's called TypeScript. I mean, wouldn't you think that the basic thing would be to type out all your values there?
Yeah.
So it doesn't have to infer, because perhaps maybe you do get an error because it was incoherent at one point.
Yes. The philosophy of TypeScript was to embrace JavaScript, and the people who designed TypeScript know that people from JavaScript background are not used to typing out the return types. So maybe that's why I think they didn't make it mandatory and make it inferable. But in any traditional language, you would have to specify the return type over here. But again, if we try adding this to the array, it will give you an immediate error. First of all, this will not be allowed. I missed the parenthesis. Fine. This too will not be allowed for you. So that's quick feedback, and generics can be used. For example, if you want to specify all properties of an array to your type, you see the IntelliSense will show you everything, and at the same time provide type safety. Everything that an array provides, this is available to you. And then at the same time, you cannot push something not valid to this object, and that's where you get to see your patterns which your engine can optimize thereafter. So, generics. And I have the abstract class. So we've seen inheritance, which is the implements, and we have seen class, how that works. Between the two, there is a concept of abstract classes. In inheritance, you can only inherit behavior, which means your construct, which I showed, can only have methods. That's something like iValidator. It can only have methods. Your class can have state and methods, and you can inherit from it. Something in between these two is abstract class, wherein you have the methods available to you, and you have partial implementation. So if you want your class to, you want to enforce some behavior in your child classes, you can do that, and you can also leave it open for extension. In this case here, I have an abstract class called course, and this has 3 private variables, and I want something like set syllabus to be fixed, that every child which inherits from this course class should have the syllabus set to something that I specify. But at the same time, each course can have different grading, different kind of, some can have a bell curve kind of a thing, some can have fixed, everybody gets an A+, that kind of a grading. If you want to specify that, you have an abstract method over here. So it's half inheritance, half you mandate what your child classes can do. And one more thing about constructor, you can, the default constructor has no parameters, and you can have constructor like this, which is when the new method is called, you have this constructor, and that has parameters. So you bypass the default constructor over here, and you set the variables. You can also actually omit all this and have your variables declared here directly. This is just syntactic sugar. I mean, if you feel.
But it is sweet. And the Java people will actually should say it too.
That's awesome.
So this defines your abstract class state for you. And if you see any client, I'll show a class which inherits this, and you will be able to see the public method, but you'll not be able to see the private variables of it. But in the JS version, it's all going to be the same. Okay, I inherit a class from this. I could have a subject mathematics, for instance. I don't know. Okay, again export. Again, we name the file as the class name, and it extends. So in case of interface, you implement. In case of abstract classes and other classes, you extend. We extend the class. It's implements, I think.
It extends, yeah.
Extends.
But you have to like import course from.
You should actually give me.
Usually it
give
auto
me
imports it, but
directly.
maybe it's not smart enough to.
Sorry?
Maybe it wasn't smart enough to import it automatically.
No, it does. It was smart a few minutes back. I don't know.
You need the dot stuff.
Well, import course from.
Just copy that line.
I can copy it. It will save time.
Sometimes-
Well, it does embrace JavaScript. It cannot run away from it entirely.
Yeah. I'll try one more time. Should have worked. Anyways, we'll import it.
We'll edit the video and have it automatically.
Yeah, Joe's good at that stuff.
But now it became smart again, and now it's telling you that it does not implement the inherited method, which is and it gives you the I mean, if you try using it, it will give you the error over here basically. And here you can have your class, but if you see this dot, it will give you only these two methods for this, and that's because in inheritance your private members are never inherited, protected are inherited to one level, and public are inherited forever. So because I want the marks or the points of the course to make the decision, I'll have to make one of these public or protect. Let me try protected first. It should work. And let's see if we get it. Yes, you get it. And you see these icons, they are from Visual Studio, but they have similar concept, but this means it's protected. You cannot go one more level beyond this, and these two are public. Because this is accessible over here, I will start. We'll keep everybody happy. We only have A's over here.
Type in the abstract as string.
Why was it like that?
Oh, I made one more mistake over here. It should be of type
Number.
number. So this instant feedback is what makes it so special. Okay, I think
Are there floats in TypeScript?
no.
No?
Not that I know of. Let's try using this.
No, but you can actually add the number to the string, and that will allow you to go both ways, the A's as A's and A's like numbers.
Oh, you mean
So
having a union type?
Yeah.
Okay.
I mean,
I'll-
JavaScript is gonna basically love it.
So this is an interesting thing in TypeScript. There's something called union types. So I could have something which is of two types, number and string. I could have multiple types also. In which case, TypeScript will not complain if I return, if I compare this with, because it can be of both the types.
I'll also say that you can basically represent the grades as both letters and numbers.
Yes.
Gonna
Okay, we'll change that.
hope, practical use.
Boom.
Oh, I
Time-
think there's a
time
lot
flew
of
by.
questions.
Okay, I think this is the basic fundamental. There is a lot of good documentation online. We can build upon this, but as you can see, the way you structure your code is different in these two languages, but not different enough. If this is useful for your project, you should. But before I conclude, TypeScript 3.7.2 was released a couple weeks back, and there are two very interesting features in it. One of them is optional chaining, and if you see, a lot of code often is littered with if a is equal to null, Then if A is not equal to null, then call A dot B as don't do anything. This will fix that. If A is null, it will not call the property B of the class A or object A. Otherwise, it will go ahead and call it. This is again syntactic sugar, but it will remove a lot of unnecessary repetitive code from your code base. And the second is nullish coalescing. Basically, you have those ternary operators which say if something is true, question mark, then first thing, else colon, second thing. This will omit that. If
The thing on the left is
Yeah,
undefined or
yeah,
null.
yeah, if that's
It'll
right,
return the
that-
thing
right,
on the
right.
right.
if this is undefined, if A is undefined, give the value B, return the value B, else return the value A. So these are pretty interesting features among the others of TypeScript, but you can again check those out. There's lots of good documentation online, and the community base and interest in TypeScript is just growing every day because it embraces people like us who are not from traditional JavaScript backgrounds. With that, happy TypeScripting.
Questions? All right, I have questions. One, I saw you're doing source maps. Do those source maps point to TypeScript? Or do
Yes.
they point to the generated JavaScript?
TypeScript.
TypeScript.
Yeah.
How far? So the project I'm working on is all JavaScript, but we have a branch where we're exploring TypeScript, and we all think it's pretty cool. But like this new release with optional chaining and nullish coalescing operator, it kind of shocked me because I was like, oh wait, you can't. Like, how far behind is TypeScript? Because at this point, like, we've been in regular JavaScript, obviously transpiling with Babel, we've been using optional chaining for the better part of a year and nullish coalescing most of that time. And now we're looking at partial application syntax. I'm trying to figure out what else like we think is really moving along. I've been exploring, like, I think you can do TypeScript compilation through Babel natively now. Can you also implement like Babel plugins and stage 1, 2, 3 features? Or if you go TypeScript, are you locked into only what TypeScript's like? Could you have used optional chaining before this new release?
I think TypeScript has a something compiler flag called allow future features. So before something's become live or part of ES standard, you can use it in TypeScript. So I believe this was always available, but now it's a part of the release.
Okay.
But this was always, again, I mean, I'm no expert
Well,
on
let me
TypeScript.
interject though, because I think that basically the answer is this. If I recall correctly, the mission statement is whatever passes in JavaScript will pass in TypeScript. So the only thing that I can think of, and don't quote me on it, but I'm like 80% confident that basically the coalescence was part of it the moment it was released because of how the TypeScript relies on JavaScript. So it would not, if it's not syntactically disallowed, it will go through and then it's going to work as expected. Again, that's my interpretation of what I read.
But TypeScript's not going to transpile stage 1 stuff that it doesn't support, right? It doesn't have built-in transpiling of
What I'm
not stage 4.
But you're asking the wrong question. TypeScript is not designed for JavaScript developers.
I know.
Well, no, but
But you're asking it from a perspective of a JavaScript developer.
Well, and a former C# developer.
Right.
Everybody can do TypeScript.
well, let's put
No,
it this
they
way.
can't,
What
right,
I'm
but-
what I'm capitalizing on is the statement basically if it works in Java, and I mean
JavaScript.
JavaScript, yes. Syntactically,
They're pretty much the same.
yeah, right. Syntactically, if it works in JavaScript syntactically, TypeScript will allow it.
Right,
So
but
consequently,
in the browser or anywhere else right now or in Node, partial application syntax won't work. And not without a Babel plugin or Babel node
Yeah,
or
your
something.
optional chaining, I don't think is worth with transpiler. Right?
Right. I mean, we're there now though. That one is gonna make it everywhere. I really think it's like stage 4 now, so it's pretty much guaranteed. Huh?
So you know it doesn't work.
What doesn't work?
What you're saying about the partial application syntax and those things.
No, I know those things don't work, but I can make them work with Babel.
So,
With
you're-
very simple. I can
so
just-
can TypeScript be replace Babel with that same?
No, what I'm saying is, can I do the same thing in TypeScript or not? Can I use, future versions of JavaScript or potential future versions of JavaScript in TypeScript the way that I can right now with Babel?
Yeah.
Not with type. You can't.
It's effectively a.
Let her type it.
What I
Tell
mean
me
is
we
we've
can
been
find out
using
right now.
optional chaining for a long time now. But TypeScript just got it, and so what I'm wondering is like, what did you do before
99.5%
that?
of the population haven't.
That's what I'm wondering.
I guarantee you 100% of .NET developers have not.
Here's something else. Notice that she can actually target the different versions of JavaScript.
Well,
Which
you
means
do that with
that
you do that
collection-
with Babel too.
Hold on a second. I'm asking you your question. Basically, which means that if the TypeScript does not or would not support the coalescence, she will be unable to target the older version. Okay.
So the
Yes.
question is probably, what's ES next mean?
Right, exactly. That's the real question right there.
That's whatever is.
What's an ES? So
Either draft or
the
something?
feature you're talking about is an ES next. and
It's
your
in
answer
an
is
ES
yes.
maybe.
Right.
So basically, what it means is that if in TypeScript you use the coalescence, but you use the target that's lower than the coalescence was available at, it should still compensate it, so it works.
Yeah.
Okay, but the reverse, meaning that if you're gonna basically do the coalescence, okay.
Are you 100% on this? This sounds theoretical.
Okay.
If you're not 100%, stop typing.
Think about how it works. Number one,
Type more.
I remember quite vividly this statement. If I'm mistaken on this statement, then obviously I'm going to be on the very thin ice. But the statement was that if the syntactically code is Java compliant, TypeScript will allow it. Okay, which means that if you're going to extrapolate it, basically
You got 1 minute left.
Well, I pretty much answered your question. I think that basically you can go back and forth, but if you want to transpile it, it has to be.
Well, I mean, TypeScript
compiled.
has to be transpiled anyways. I'm just wondering if we can transpile.
What's an example of a partial application? Is that something
Why
you
don't you
type real
let
quick?
us show you?
Yeah.
It doesn't matter.
She doesn't have
What it looks
vowel
like
installed.
is you create a function that takes in an argument and then it takes in a question for another. It's literally like a shortcut for curry.
Okay, so you can just type it.
So Joe,
And we can find
so
out.
the
Yes.
TypeScript compiler by itself can't do modern JavaScript things until they're implemented in the TypeScript compiler.
Right.
So the usual pattern for using TypeScript and using modern JavaScript is to still use Babel, but to use the preset, the TypeScript preset. So that gives you the types, plus you get your Babel plugin.
So you can do your transpilation with Babel
Yep.
and also have your Babel plugins.
Yep.
Cool.
Yeah.
Thank you.
Because TypeScript alone can't do it.
You are
If you're in an old version of
Fancy
it, like she
combo.
might have it now because it has the
The latest.
3.72. Right, but if you were on like 3.5, 3.4, you didn't have it.
And it's not going to
Cool.
allow you ways to use.
I forgot that we can do that, the Babelification. with
I know that was a
TypeScript.
big deal that Babel like natively supports TypeScript now.
Type what
And
Thank you very much.
Anyway, that's what we don't use. Come on.